Good afternoon, Farmington High School, or good morning. I only teach this class in the afternoon, so good afternoon. I can add and subtract radical expressions. So now, after we taught you how to simplify, we're going to take it one more step farther and teach you how to add and subtract them. So simplifying the expressions. Let's review this a little bit. So there's kind of two ways you can do this. Option one, you can do 4 and 10, all right? Obviously, you could have done 8 and 5 if you wanted, but I get 2. 4 times 10 is 2. 2, this is going to be 2 and 5. So a lot of what we were doing was 2 times 2 times 2 times 5, square root. Then remember, it takes 2 to pull it out front, so I probably would have wrote this as 2 times square root 10. This is the best answer. So you could have did that factor tree and that prime factorization. Over here, though, I would probably split this into square root 4 times the square root of 6 times x times x times x times x times x. Kind of run out of room there. All right. These two come out front. Maybe these last two come out front. So what I should be able to see is the square root of 4 is 2. I have 2 x's coming out front, so times x times the square root 6. And then this x is still here, so times the square root of x. So the best answer here is 1 and 1 would make 2x squared times the square root of 6x. One thing to notice is I put this little tail under it to show that both of these are under the square root. That's just something I personally do. Obviously, up here in 40, you can tell the computer doesn't have a tail. I started putting a tail to eliminate confusion. All right, so let's talk about adding and subtracting them. We got this Facebook thumb, all right, right here. You should see this is for when the 5 and the 5 are together. Okay, this is a 5 and a 3. So one thing you can think of is this is like a 4x plus 7y. We don't add those because they're not like terms. If this, we change square root of 5 to x, well then it'd be like 4x and 7x. We can add that to be 11. So make sure if the square root's the same, that's like combining like terms. They have the same number under the radical. So if I move forward, 5 square root of 3, 2 square root of 3. So this is, in theory, if I did this off to the side, 5x plus 2x, you used to tell me was 7x. This is the same thing. 5 and 2 still add to 7. 7 square root 3 is the final answer. When I look at this one, square root of 2, square root of 2. So those are the same. So usually maybe we'll underline those. 2 minus 6 would be a negative 4 square root 2. All right. Square root of 5 is by itself. I might write that out front. So we know it's the square root of 5 minus 4 square root x. It's not square root x. Don't write that. Write that as square root 2. All right. So 5 minus square root of 5 minus 4 square root 2. You could also wrote negative 4 square root 2 plus square root 5. These two that are circled, all right, they're equal. Those are the same things. Make sure you remember that from algebra. Moving on. All right, so now they'll throw some variables in it, things like that to try and confuse us. Circle these. These are similar. This is a negative 3 here. So 5 minus 3 would be 2 square root x plus square root 2. You're done. Once you understand these and get the hang of these are pretty simple. Now, this is fun here, because I would write this as 4 square root 3. I would have split this up. This would have been square root 9 and square root 3 to me, right? So what I probably would have did is wrote a minus and multiply. Then I would have wrote 4 square root 3 minus the square root of 9 is a 3 square root 3. Funny thing, these square root 3's are the same. 4 minus 3 is 1 square root 3, or just square root 3 is a very, very good answer. So you make sure that you know that a little bit. Okay? And then flip over to the back. I thought these were on the back. So now we got some work to do. All right, all three of these appear to be different, but we got to see what work we can do. So I've been writing this as 2. The perfect square that I know that goes into 12 is square root of 4. So I would write square root of 4 times square root of 3. That does not change the value. We just split it up. Minus 3. Square root of 27 on the other side was square root of 9, square root of 3. And then plus 2. This would be square root 16 and square root 3. That one I just have experience doing. You probably could have got 4 times 12, and then it would have been 4 times 4 times 3. And I look at 4 and 4 and know it's 16. Alright, so then what I do, alright, is I would probably take the square root of stuff. Minus 3 times square root 3 plus 2 times 4 square root 3. So I'm showing every step right now. 2 times 2 is 4 square root 3. Minus 3 times 3 is 9 square root 3. Plus 8 times square root 3. So if you don't like the perfect squares, and the perfect squares here, I've underlined in red, alright? If you don't like using the perfect square thing, then you're going to have to do a factor tree. Either way, you have to get this starred line, because now is when we can combine like terms. So 4 minus 9 would have been negative 5 square root 3 plus 8 square root 3. Best answer here is 3 square root 3. So if you don't like the rest of the notes video, I'm going to do it with perfect squares, which is the red underline. If you don't like that, don't do it. Your option, though, is the factor tree. So once again, I'm going to do this perfect square thing. It'd be 3 square root 4 square root 2 plus 5 square root 16 square root 2 minus 4 square root 9 square root 2. Here's my perfect squares. 4, 16, and 9. So I'm going to change those to 3 times 2 square root 2 plus 5 times 4 square root 2 minus 4 times 3 square root 2. When I do that, I'm going to get 6 square root 2 plus 20 square root 2 minus 12 square root 2. 6 and 20 make 26 square root 2 minus 12 square root 2. And I'm showing every step right now, so there should be no confusing. Need to be able to get 14 square root 2, and that's using perfect squares. If you don't like perfect squares, then we got to find another way for you to be able to do it. Alright, so now we're going to go to some word problems. Well, not really a word problem, but find the perimeter of this rectangle. Alright, we need to know that this would be 3 plus 6 square root 2. Alright, these sides are equal. Ooh, this is square root 8. Now, square root 8 to me is actually looks like square root 4 square root 2, which is 2 square root 2. So I probably would have wrote 2 square root 2 over here. I would have scribbled out the 8 and wrote 2 square root 2. Now, perimeter. Perimeter at this point in your life needs to be to add up around the outside. So usually I just start in a corner. So 3 square root 3 plus 6 square root 2 plus 2 square root 2 plus another 3 plus 6 square root 2 plus 2 square root 2. So now I went all the way around the figure. Now we get to combine like terms. First thing I would probably do is do the 3 and the 3. 3 and the 3 are easily 6. 6 and 2 make 8. Plus another 6 is 14. Plus 2 more is 16. So this is 6 plus 16 square root 2's. That needs to be what you can get. Alright? Now the other part of this is yards. So we're starting to get to word problems again. You should have word answers. You and a friend are working on a sailboat. The distance d miles you can see to the horizon can be modeled by the equation distance equals the square root of 3 times h divided by 2. So where h is your eye level in feet above the water. Your eye level is 32 feet. So 32. And your friend's eye level, so we got 2 of these to find. So distance is 3 times h. H this time, height is 18. So this is your friend. This is you. You, friend. Alright. Now, distance you can see is going to be 96 divided by 2, which is 48. We did 48 earlier. I told you it was 16, 3, which is 4 square root 3. Then we have 3 times 18. 3 times 18, that's 54 divided by 2. So distance here is 27, square root 27. And I told you that one we've done a few times. That's going to be 9 times the square root of 3. So the distance there is 3 square root 3. Now it says write an expression that shows how much further you can see than your friend. Well, to show how much further I can see, I would have said 4 square root 3 minus 3 square root 3. Okay? The 4 minus 3 is going to be 1 square root 3, which is equal to just square root 3 miles. So you can see about, that should be about 1.7 as it works. So square root 3 miles. Alright? That's a pretty good problem. Alright? Now here's velocity. Alright? Suppose you know feet per second, height is h still, are related to the following equations. Suppose you are a pole vaulter and reach a height of 20 and your opponent reaches a height of 16. So velocity equals 8 square root 20. So that's going to be you again. Opponent. Okay, and the opponent reaches a height of 16. So velocity equals, it is 8 square root h, but your opponent is 16. So you have velocity equals 8. I know square root 4 goes into that. Square root 5. Velocity equals 8 times 4. Velocity of your opponent is 32. I'll rewrite it for some of you so you don't go goofy. 32. Alright, I would have said here we have 8 times 2 times square root 5. So velocity here is 16 times square root 5. Now it had asked for the expression that shows how much faster you ran than your opponent. So you are 16 square 5. So to figure out how much faster you are, you need to subtract. So this is the expression. Now it says to simplify. That is actually simplified. But now you need to find the nearest hundredth. Hundredth is 2 decimal places. So approximately 3.78 feet per second when you do that in your calculator. So this is also a good time to practice using your calculator. Make sure you can get that. How I would do it is I would do the square root of 5 in my calculator. I'd hit enter. I'd multiply that answer by 16. You're going to get an answer of about 35.778. And then you're going to subtract 32. You're going to get 3.778. And then you're going to round to 3.78 like I have shown you to do. Okay, that concludes today's notes. Please check with me to make sure you are filling out your goal setting sheet. You are on top of it. You are going to finish on time. Have a wonderful day. Goal set, please.